double click on this footprint library, here it is, and left click on tools, left click on footprint wizard. The first component what we are going to create is the SMD resistor. Left click on the next button, left click on resistors, left click on these units and left click on metric, left click on next button, left click here, left click to select SMD component, left click on next button, and here we need to put values, we need to specify the size of the path which we would like to use in our footprint. Go to DigiKey, find our resistor, left click on datasheet link, scroll down a little bit, and here is information about the recommended footprint. Here you can see it. For 0805 resistor we need to use this row which is here, and we would like to use reflow soldering. You can Google what is the difference between reflow and wave soldering, but this is basically the soldering in the oven. That's what we normally use. And for reflow soldering we need to use the path size 0.7 by 1.3 millimeter. 0.7, 1.3, left click on the next, and the size or the distance between middle of the paths is L 1.2 plus A plus 0.7, that's 1.9 millimeter. 1.9. Next, this is not really important, just left click on the next button and call the footprint R0805. Left click on next and left click on finish. Now in these tabs down here, left click on PCB library. This was automatically created by the footprint wizard, and we need to adjust few things. So first change the units, left click on these millimeters down here. Now left click somewhere into empty space in the canvas, press G and change the grid to 0.1 millimeter. If you like, you can change the grid also here. Just double click in this grid manager, double click, and you can set the grid also here. Okay. We are going to work with this top overlay layer. This is the seal screen. This is usually the white color on the PCB. So left click on this tab to activate this layer because we would like to work with this layer. Now left click to select a line, and we are going to move it. Just hover cursor over this selected line, press left button on your mouse, hold it down, hold down the left button and move this line like this. Again, left click, now left button, hold it down and move it. Left click, left button, hold it down and move it. Left click, this is just half of the line, so we are going to delete this half of the line. Press delete on your keyboard. Now left click again, and we would like to adjust the size of this line. So wait until you have until the cursor has this kind of shape. Left button, hold it down and make it a little bit longer. Now left button, hold it down and move it. Very quickly, the other layers, what you can see here, are the top layer. This is the layer, this is the copper. So this red layer, these are the paths where you will solder the component. Then the next important layer is top paste layer. This is the place where the solder is going to be placed on your path. Basically where the tin will be placed when your board is soldered by a machine. And This is also important layer, top solder. This is the mask layer. This area here will not be covered by the color of the PCB. So usually everything here will be, for example, green. If you have green PCB, everything here will be green, except these areas which are here. There will be no green color. So the pads, there will be no green color on the pads. Okay, so these are the important layers what you need to know about. The top solder, this is the area with no green color. Top paste, this is the area for solder where the tin will be placed. Top overlay, this is usually the white color, the white lines around the components. And the top layer, this is the copper where the pads are located. We are going to check out how our footprint, how our component is going to look in 3D view. Left click on view and left click on 3D layout mode, or next time I'm going to use number 3. Okay, so you can use the menu, or you can simply just press number 3 on your keyboard to go into this 3D view. If you press number 2, you will go back into 2D mode, to this one mode which we have now. So left click on this 3D layout mode, and to manipulate in this 3D view mode, you need to use Shift, hold it down, and press right button on your mouse, hold it down, and move the mouse. This is how you will rotate the view. Or simply do not use the Shift, just press right button on your mouse, hold it down, and you can pan the view like this. Go back into our 2D view, and we are going to place 3D model on our footprint, so we can build, or we can create 3D model of our board. You can press number 2 on your keyboard, or you can press left button on the view and left button on 2D layout mode. Go to DigiKey, and if you like, you can download 3D model through this link directly from DigiKey. I tried this 3D model. It wasn't exactly what I would like to have in this video, so we are going to download different 3D model. Just Google for 3D Content Central, this, okay. Left click. Now you need to register and you need to log in to be able to download 3D models from this website. The registration is free, so just you can just do it. And once you are logged in, we are going to search for 0805 resistor. Enter. Use this 3D model from Caesar. Okay, left click. Now here select step file. We don't want to have it zipped. I don't want to remind to rate this model. Left click to download. And left click on this link. Once you download 3D model, here it is. I'm going to place it inside of our project. This is our project, Fedevel Academy Late YouTube project. I'm going to create directory. Let's call it 3D models. And I'm going to copy it here. Go back to Altium, and once you download 3D model of your component, we can place it into our footprint. All the 3D models are going to be placed on this mechanical 1 layer. So be sure this mechanical 1 layer is active. Just left click on this tab. Then to place 3D model into footprint, left click on place and left click on 3D body. Go into properties panel, left click on generic, left click on choose. Find the 3D model which we have downloaded. It is inside of our project, Fedevel Academy Late YouTube project 3D models. This is the resistor 3D model. Left click and left click to open. To place 3D model into footprint, just left click, and to cancel the command, press escape. Now press number 3 on your keyboard to see our 3D model in 3D view. We would like to place this resistor on our footprint. So first we would like to align these parts of the resistor. We would like to place them on the PCB, on the same level where is the surface of the PCB. To do this, there is a very nice command in Altium. So just left click on Tools, left click on Select 3D Body Placement, left click on Align Face with Board. Left click to select the 3D model what you are going to work with. So just left click here, and then select the surface which is going to be placed on the PCB. So this part or this one, just left click. Okay, so now the resistor is basically on the PCB, we just need to rotate it. To rotate this, it is much easier to use 2D view. So press number 2, go back to 2D view, and we would like to rotate. This is the 3D model. We would like to rotate it. Be careful where you are hovering the cursor, because that's the place where you will be holding the 3D model. You don't want to hover a cursor here and then press a left button, hold it down, because then you will hold the 3D model in this corner. We would like to ideally hold this 3D model in the middle, because then it's easier to place it. So hover cursor somewhere in the middle, use left button on your mouse, hold it down, press spacebar to rotate, and place it exactly on this origin. So just release the left button. Press number 3 to double check our placement. Okay, it looks like 3D model is placed correctly on the footprint. Press Shift, hold it down, press the right button on your mouse, hold it down. You can double check if everything is okay. Sometimes it is very useful also to measure these dimensions of 3D models, because we have downloaded this 3D model from the internet. We don't know if it's correct one. So if you would like to measure distance of this, or if you would like to measure dimensions of this 3D model, just left click on Tools, select 3D Body Placement, and left click on Measure Distances. First, select the 3D model where you are going to measure, so left click here. And now just we would like to measure the height, so left click on this corner and left click down here, 0.6, okay. Left click on this 3D model, left click on this corner, left click here. Length is 2 millimeters, and left click, left click, left click, 1.25. Let's go back to DigiKey, just press Escape, go to DigiKey, and dimensions of our resistor are L is 2 millimeters, width is 1.25, and the height is 0.45. Our model is 0.6 millimeter, but that's okay. So perfect. This 3D model is great. We can go back to 2D view and we can finish this footprint. Press number 2, go back to 2D view. Our footprint is almost finished. We just need to add one more layer. We are going to add assembly drawing layer. You remember assembly drawing layer? It is used in documentation usually to create view like this with position of all the components on your PCB. It is also used here. So on the assembly drawing layer, we would like to create outline around our component, and we would like to place their designator. To add a new layer into your footprint, just left click on this color down here, yeah, left click, and you will see this view configuration panel. Here you can see all the layers. in your footprint, and to add a new layer, just hover cursor in this area, for example somewhere here, right click and left click to add mechanical layer. I'm going to use mechanical layer 29. That's what I normally use for assembly drawing layers. So left click on mechanical 29. Okay. And if you have a look on this layer now, it will be empty. I'm going to speak a little bit about the single layer mode. To make it easier to work in Altium with all the layers, there is one really useful command which is called single layer mode, and you can activate this command when you press Shift S on your keyboard. So press Shift, hold it down, press S, and this is something called single layer mode. Only the layer which is visible is the active layer, the one which is selected. If I select this top layer, you can see now this is the active layer, and all the other layers, they are grayed out. This is very useful many times if you would like to see what is on one specific layer, or it is also very useful if you would like to work with components which are only on specific layer. Because if you use, for example, selection, if I try to select something like this, see, only what is selected are the objects which are on this active layer. All the other objects, they are not going to be selected. If I go, press Shift S, and press Shift S again, if I try to select everything like this, see, all the objects will be selected. If I'm in the press Shift S, if I'm in this single layer mode, only these objects are selected. This is sometimes very useful. As you can see, there are more single layer modes. If I press Shift S again, this is the single layer mode where everything is hidden and you only see this active layer. Or if I press Shift S again, now I'm back in the normal view. Usually I only use this single layer mode. So what I'm going to do, I'm going to change preferences in Altium, so I don't have to always go through this mode, which I never use. Left click on Tools, left click on Preferences, go to PCB Editor, Board Inside Display, and uncheck this, Hide Other Layers. Leave only this gray scale other layers. So when you press Shift S, only this one command will be active. Okay, press Shift S again. That's exactly what I would like to have. Okay, let's go back into our assembly drawing layer. Press Shift S to activate single layer mode, and left click on this mechanical 29 layer tab, just to see what is on this new mechanical 29 layer. There is nothing on our assembly drawing layer, and very simple way to put here the component outline is to copy it from this top overlay layer. So just press left button on your mouse, hold it down, select all these. Now press Ctrl C, or you can right click, copy. This is very important. Now Altium is waiting for the reference point. So we have selected everything, our copy command is active, but you need to specify where you would like to hold the selection when you will be pasting these components. So ideally we would like to hold it in the middle of these components. So left click somewhere here. Now go on the mechanical 29 layer, left click here, and left click on Edit, left click on Paste Special. Check this, Paste on current layer. We are going to paste it on mechanical 29 layer. Press Paste, left click on this Paste button. See, I'm holding this new component or new outline which we are going to place on our mechanical 29 layer. I'm holding it in the middle. That's exactly what we would like to have. So place the cursor on this origin and left click. Left click somewhere into empty space to unselect everything. You know what we have done? We have copied these top overlay lines, which are here. We copied them and paste them here on this Mechanical 29 layer on our assembly drawing layer. To place reference designator on assembly drawing layer, left click on place and left click on string. Be sure you are on Mechanical 29 layer, okay? That's the layer where we are going to place the text. So left click on place, left click on string, go into properties panel, delete this string, just select it, press delete, and we would like to put here something really special, because this reference designator is going to change, depends on the component which is placed on the PCB, okay? So reference designator for every component is going to be different. And for this, we are going to use variables. So we cannot place just string here, we are going to put there variable. To place or to see all the variables which you can use, just left click on this plus button here. And our variable is called dot designator. Left click here. So this text is going to be replaced in the PCB, it will be replaced by the real designator for specific component. Change the text height to be 0.7 and change the stroke width to be 0.1. Okay, and left click somewhere here. Right click to end this place string command and press Shift S. Don't forget to save the library, just press this button up here, left click. Now we are going to create footprint for the LED. Left click on Tools and left click on Footprint Wizard. Left click on Next. We can use resistors, left click on resistors, left click, select metric, left click on the next button, left click, select SMD component, left click on next button, go to DigiKey, find our LED, left click on datasheet link, scroll down, and this is the recommended footprint. So for the path size, we need to use 0.8 millimeter. Change this to 0.8, 0.8, left click on next, and the distance between the paths is 1.65. Left click on next. Just leave this default, left click on next, and name the new footprint like LED 0603 green, or just use G like green. Left click on next and left click on finish. We are going to adjust this seal screen or this top overlay layer. Left click on this top overlay tab to make it active. Be sure the units are set to millimeters and the grid is set to 0.1 millimeter. Left click on this line, left button hold it down and move it like this, okay, leave some space here. Left click on this line, left button hold it down and move it. Now, this is a special footprint. We need to mark one of these pins as a cathode because it's LED. Which of these pins is cathode? Do you remember? If you are not sure, you need to go back to schematic symbol library. So go down here. I cannot see the projects here, so just use these arrows. Left click here, okay. So left click on projects, double click on schematic symbol library, left click on this schematic library tab, and left click on this LED. Pin number 1 is cathode. Go back into our footprint library. You can go through these projects, or you can simply just left click on this tab up here. And pin number 1 is the pin which we need to mark as the cathode. So simply just move this side, left click here, left button, hold it down and move it. Left click here, press delete on your keyboard, left click here, hold the cursor here, left button on your mouse, make it a little bit longer, and move this line on X position minus 1.9 millimeter. Okay, watch down here, left button, hold it down and move it to position minus 1.9, like this. Release the left button, left click on place, left click on fill, left click into this corner and draw this rectangle. Make it like 0.4 millimeter wide, so like 1, 2, 3, 4, and left click. Right click to exit this placement command and left click into empty space to unselect everything. I'm going to make it a little bit nicer because this space is a little bit bigger than all the other spaces here. So left click, left button, hold it down and move it. Left click to unselect, view, fit all objects. Okay, we are ready to place 3D model into our footprint. So go to DigiKey. If you like, you can download 3D model directly from here, but we are going to use 3D Content Central again. So right click, duplicate, and search for LED 0603, enter. Go on page number 4, and we will use 3D model created by Samuel John, because I like this one. So left click here, left click to select step file, left click, uncheck zip, uncheck remind me to rate this model, left click on download button, and left click on this download link. Here is the 3D model which I have just downloaded, and I'm going to copy it into our project directory, FEDEVEL Academy LED YouTube project 3D models. Go back to Altium and we are going to place 3D model on our footprint. First, be sure the mechanical one layer is active, so left click on this tab, left click on place, left click on 3D body, left click on generic, left click on choose, select the 3D model of our LED, left click here, and left click on this open button. Left click to place 3D model into our footprint. Press escape to cancel the command. Press number 3 to switch to the 3D view. Now notice this special mark here. This is very important because if you go into datasheet, you will see that this special mark is pointing to pin number 2, which in this datasheet, pin number 2 is the cathode. So in our footprint, we would like to place this pin on our cathode pin of our footprint, on this pin here. See, this is the mark for the cathode pin. So we would like to place this pin on this path. Okay, so first place this LED on the top of our PCB. So left click on Tools, select 3D body placement, left click on Align Face with Board, left click on this 3D model, left click on this pin, press number 2, go to 2D view, Hover cursor somewhere in the middle, left button on your mouse, hold it down and press spacebar. Go back into 3D view, press number 3 on your keyboard and have a look from the bottom, where is the mark. So press shift, hold it down, press right button on your mouse, hold it down and have a look. Okay, here is the mark, so this is the cathode pin and we would like to place it here. So we need to rotate this 3D model. Left click to select the 3D model. Left button, hold it down. Oops. Like this. And press space bar to rotate. Perfect. Release the left button, press number 2, go back into 2D view mode. And hover cursor somewhere in the middle, press left button on your mouse, hold it down and place it like this. Release the left button, press number 3 to double check if the 3D model is correctly placed on the footprint. Okay, so this is the cathode, this is the marking, press shift, hold it down, press right button, hold it down and double check everything. Perfect. Press number 2, go back into 2D view. Only what is missing is the assembly drawing layer. So press Shift S, zoom out, left click on top overlay tab, left button, hold it down, select all these, right click, copy or Ctrl C, left click into middle on this origin, left click on Mechanical 29 layer tab, left click on edit, left click on paste special, be sure paste on current layer is checked and left click on paste button. Left click exactly on this origin, left click somewhere into empty space, view, feed all objects. In case you would like to copy something from existing footprint, you can very simply do it. So let's say we would like to copy here the dot designator string from the other footprint, from the resistor footprint. Left click on PCB library, go into our resistor footprint, left click here, left click on designator to select it. Now Ctrl C or just right click, copy. You can use any point you like, but I would like to hold it somewhere here. So left click here, go back into LED footprint, left click, and now press Ctrl V or just right click, paste, and you can paste it somewhere here, left click. Because this is a very special footprint where pin 1 is important, very often into this kind of footprints I also place a circle close to the pin number 1. But I'm not going to do it right now because a little bit later I would like to show you something. So let's say our footprint is ready and everything what we have to do is just press save. We are going to create the last footprint for the connector, left click on tools and left click on footprint wizard. Left click on the next button. This time we are going to use this deep footprint wizard. This is close to what we would like to create. Left click on select unit, left click on metric, left click on next button, go to DigiKey, left click on this link to open datasheet. The recommended hole is 1.2 millimeter and distance between the pins is 2.54. So this is going to be 1.2. This here is going to be 1.6. And this here is going to be 2 millimeters. How do I know? This is how I normally use it. If you like, you can change it later, it's not a problem. But this is the normal size around the through hole pins what we use in our footprints. Left click on next. So the distance between these pins is 2.54. This is not really important because we will delete these pins. Left click on next. Not important, just left click on next. 4 pins. 1, 2, 3, 4. And we will delete these 2. Left click on next. And let's call it header 1x2. Left click on next. Left click on finish. Shift S. We are going to adjust this footprint, zoom out, press left button, hold it down, select all these tracks and also these pins which are here, release the left button, press delete on your keyboard. Now zoom in, and we would like to move this reference point, this origin. This is the point where x and y is 0. Have a look down here, can you see it? If I move cursor here, x and y is 0. And we would like to move this reference point between these pins, because then it will be easier to draw the outline around this connector. Left click on edit, select this set reference and left click on center. See, it's moved, now it's between the pins. Go to datasheet, and we need to see what is the size of the outline. So for a 2-pin header, dimension A is 200 mils, and this one is 230 mils. Go back into Altium. We would like to work with mils, so left click here, and we would like to change the grid. We would like to change it to 5 mils. So press G or press G on your keyboard and select 5 mil. We are going to draw the outline around this connector. It's very important you watch this X and Y position of the cursor. Yeah. We are going to draw the outline on the top overlay layer. So left click on this top overlay tab, left click on place, left click on line. Be sure the line width is set to 0.2 millimeter. Just left click here and write 0.2 millimeter. When you press enter, it will be automatically converted to mils. So press enter. And do you remember the size of the outline? 230 by 100 mils. So we would like to jump to position where? Don't forget, this is the middle. So we need to go somewhere here like 115x and minus 115x, and we need to go to 100 y and minus 100 y position here. So first we would like to jump to specific position. If you would like to jump to specific position, just press J on your keyboard. Left click on new location and jump to 115 by 100. Okay, press left button. Do not move your mouse, okay? That's important because now you are in the correct position. Press left button to start drawing the line. Watch the X and Y. Just go down here and we need to draw the line up to X 115 and Y is minus 100 mils. Left click. Again, watch the X and Y. It should be minus 115 by minus 100. Left click, go up like this, left click, and then go here, left click, right click. Go back to datasheet, and in our footprint we are going to mark where this back of the connector is located. Notice pin 1 is here, okay? So in our footprint, we need to draw the back of the connector somewhere here. The size of the mark is going to be, the length is going to be B, so that's 100 mils, and the width is going to be like 74 minus 21, that's 53 mils from the 0. Okay, let's say 55 mils. If you don't know what I'm talking about, don't worry, okay? Just draw it this way. Go into our footprint, be sure you are on top overlay, left click on place, left click on line, and now watch the Y position. Go up to 50, so Y is 50, left click. Now watch the X position, it should be minus 55. Like this, left click. Now go down, Y position minus 50, left click, and just go, left click again, and just go back here. Left click, right click, and that's it. For this kind of connector, it is very useful to mark on the silkscreen layer where pin 1 is located. Be sure you are on top overlay layer, left click on place, left click on string. Go into properties panel and change the text to be number 1. Press tab, change the text height or set the text height to be 60 mils and stroke width to 10 mil. Now just zoom out a little bit and place this number 1 somewhere like maybe like this. Left click, escape, view, fit all objects, and we can add the 3D model. Go to DigiKey, and we can directly download the 3D model from here. Just left click on this link. Here is the downloaded file. I go inside of the file and I will copy this 3D model into our project directory here. Go back to Altium. Don't forget to click on Mechanical 1 layer, so left click here. Left click on Place, left click on 3D Body, left click on Generic, left click on Choose, left click on 3D model of our header, left click on Open button, zoom out, left click to place a 3D model into our footprint, press Escape to cancel the command. Press number 3, go to 3D view. Now I had to change this a little bit, especially this background, because everything was really white. So if you would like to adjust some colors here, simply left click on the color down here and left click on view options. And at this moment, as you can see, I'm using this Altium 3D blue. Left click on tools, select this 3D body placement, left click on align face with board, left click on this header, left click on this face of the header. This is the part of the header which is going to be on the PCB, so I will zoom in so you can see better. Left click here. Okay, press number 2, zoom out, hover cursor in the middle, press left button, hold it down, zoom in, release the left button. Press number 3, double check if the outline is okay. See, it goes around the connector perfectly fine. And double check if this marking is in the correct place. So here is the marking of the back of the connector. And here is the back of the connector. That's correct. And here is the pin number 1 marking. Perfect. Press number 2. and only what is missing is the assembly drawing layer. Press Shift S, zoom out, left click on top overlay, press the left button, hold it down and select all these lines, release the left button, press Ctrl C or right click, copy, zoom in, left click on Mechanical 29 layer, left click on Edit, left click on Paste Special, check Paste on current layer, left click on Paste, and place it into middle of the connector, left click. We are going to mark where pin 1 is located, left click on Place, left click on Full Circle, and place the circle into position, I don't know, like 80 by 65, okay? So place it maybe like here, left click, 1, 2, left click, press Escape, and now here you can see the properties of this circle. So adjust the width to 20 mil, press Tab, change the radius to 8 mil, press Tab. Left click somewhere into empty space to unselect everything. We are almost finished. We just need to add the designator. Left click on Place, left click on String, change the text, delete the number 1, left click on this plus button and select dot designator, so left click here, change the text height to be 1.2 millimeter and change the stroke width to be 0.2 millimeter. Press Tab and left click. Right click to cancel the command and left click into empty space to unselect everything. Press Shift S, left click on Edit. We are going to move this reference back to pin number 1. So left click on Edit, select Set Reference, left click on pin number 1. See, it's now here. Left click on PCB Library tab, and we can delete this initial component. This component is empty. So just right click and left click on Delete. Yes. Don't forget to save your footprint library. Left click on this. What we need to do now, we need to update our schematic symbol library. So we need to update every symbol which we have created, and we need to assign these footprints to these symbols. Left click on Projects tab, double click on Let Schematic Library, left click on Schematic Library tab, and left click on the first component. To add a footprint to this symbol, left click on this Add button in this footprint container, or what is it? I don't know exactly how they call this. So left click on this Add button, left click on this Browse button. Be sure our library is selected here, and just left click on this footprint which we have created. Okay. Okay. Now, what is very important, you need to also update this symbol in the existing schematic. So always when you make any changes in this schematic symbol library, you need to do this. You need to go on this component, just right click and left click on this Update Schematic Sheets. Okay, don't forget to do this, because if you go into schematic now, and if I select this header, I will disappear so you can see it better. Here, see, there is no footprint. Now, if I go into our schematic symbol library, when I press right click on this active component, this component which is now open, when I right click here, press left button, update schematic sheets. Okay. Now go into schematic, and when you select this component, here you can see now it has the footprint. And we have to do exactly the same also for this resistor and for this diode. See, they don't have footprint. Go back into schematic symbol library, left click on this resistor, left click on add button, left click on browse, left click on resistor footprint, OK, OK, right click, left click update schematic sheets, OK, left click on this LED, left click on add button, left click on browse, left click on LED footprint, OK, OK, right click, left click on update schematic sheets, OK, left click on our schematic and double check if you can see the footprint on all the components. Perfect. You can now save the schematic and also save the library. So don't forget, every time when you need to make any changes in a schematic symbol library, or if you, for example, need to add a pin, or if you made mistake in pin name, or if you need to adjust this schematic symbol, you always need to use this right click update schematic sheets command. For example, if I would like to change this symbol, I would like to delete this. If I go into schematic, it's not updated here. I need to go here, use right click, update schematic sheets. Okay, now if I go into schematic, see, it's correct. If I go back into our schematic symbol library, if I select this, Ctrl C, Ctrl V, place it here, right click, update schematic sheets, okay, and it's back. Save, save. We are almost ready to start doing PCB layout. Only what we need to do, we need to annotate our schematic. And when I say annotate, it means we need to replace these question marks by numbers. You can do it manually. You can just left click to select the component and you can write the number here. But we don't want to do it this way because you can make mistakes. You can have, for example, two R1 resistors in your schematic, and that would not be good. There is a feature for this. You can automatically annotate your schematic. Just left click on tools, select annotation, and left click on annotate schematic. Here you will see all the current designators, and here you will see the proposed designators. You need to click on this update changes list. So left click here. There will be 3 changes, okay? And these are the proposed changes. So Altium is suggesting to change D question mark to D1. If you like this, you can just press this button, accept changes, create ECO. Now Altium is telling you that it is going to rename D question mark to D1 and all these other changes. If everything is okay, just left click on execute changes, and now all the changes were made. So close this, and you can see the R question mark is now replaced by R1, D1, J1. Our schematic is finished, and we would like to see if there are no errors. Right click on this project and left click on compile PCB project. Left click down here on this panels button and left click on messages. Compile successful, no errors found. Perfect.